Hello and welcome to another episode of Revelations from the Spinning Ball, the channel where you can get a little astronomy and a whole lot of flat earth discussion. I am Melissa Fawcett. In this episode, we are going to discuss the shape of the flat earth and the map that represents this world. This is an area I believe should get much more attention than it does. While preparing for this video, I did see a video by Simon Dan where he does discuss this topic, and I've also seen it mentioned by Dave McKeegan. But other than that, I have seen very little discussion regarding the shape of the flat earth and the map that represents this shape. Let me also say that by discussing this subject, I am merely trying to stimulate a little flat earth discussion regarding the shape of their world. This is definitely an area that needs a lot more debate and a lot more discussion. Have you ever sat staring at the azimuthal equidistant map of the flat earth, contemplating how anyone could possibly think this represents our planet? Have you ever wondered why flat earthers run around claiming there's no curvature when their world is curved? This is a circle. Now, I know what you're going to say. You're going to say, Melissa, the flat earth has a map grid superimposed on it, and yes, the sun does revolve above the flat earth in a circular pattern, but the flat earth is, well, it's flat, dummy. I don't know about that. I think it's debatable, highly debatable. Let me show you what I'm talking about. First up, let's discuss the fact that the flat earth uses the wrong coordinate system for their world. I understand that this map is really a projection of a globe, but if you believe it's literal reality, you need a coordinate system more conducive to flatness. The longitude lines are quantitated in degrees, which is fine because they form the circular part of the map. But the latitude lines are also quantitated in degrees, even though they are supposed to represent a flat surface. Naturally, this should be your first clue that this world is curved in two directions, but we'll pretend it's flat for now. Anyway, using degrees to describe a straight line seems highly inappropriate, at least as far as geometry is concerned. The definition of a degree is given as a unit of measurement of angles, 1/360th of the circumference of a circle. We'll come back to this in a minute. For now, let me say that flat earthers definitely need to develop a new coordinate system for their world. They should probably have an XY coordinate, maybe an angle thrown in, sort of like they use for circles in geometry. There's no real excuse for not doing this. It only takes some effort. There's no lack of funding, lack of equipment, or a deep state conspiracy to stop you from putting in the effort and creating a usable map. If I believed the world was flat, you'd be damn sure I would create a map. Let's move on. Now, I know there is real curvature on this map because of simple observations made during the spring or autumn equinoxes. Anyone can make these observations, and I suggest you do just that in a few weeks during the upcoming equinox. On the equinox, the length of day and night are about the same. The sun rises due east and sets due west for all observers. If I happen to be, I don't know, on the equator, the sun will rise here because we know that the sun will be up for about 12 hours on this particular day, right? If I use a compass and face due north, how do I turn to get myself facing due east? Well, I can measure out 90 degrees or make a perpendicular line. Whatever method I use, the end result is exactly this way, which is not where the sun is rising, at least according to this depiction. On the flat earth, when I turn exactly east, I should be facing the sun at sunrise so that it will match observations. When I face east at sunrise on the flat earth map, I'm actually looking right here. I'm looking around the bend. The earth is curved. When I turn exactly 90 degrees right of due north, I'm looking right here because curvature. Of course, some flat earthers will say, hey man, it works like that on the globe. About 4 or 5 years ago, Globebusters devoted an entire episode to this equinox discrepancy, and Jaron went into a big demonstration trying to show how, on the globe, when we look east, we are looking towards the equator, so it's kind of the same thing. When you look east on the flat earth, you are looking towards the equator. My response to this is exactly because curvature. The flat earth is curved. But what about perception? Can we detect this curvature of the flat earth? First, someone did create the map, and second, it sure seems like a lot of flat earthers think it's detectable. I mean, they claim that airplanes travel across the surface like this. How do they fly this way? If I need to travel southeast, what's my bearing? Do I fly the traditional direction of southeast, or do I adjust for the 45-degree discrepancy and fly in this direction? It's a bit confusing because you'd think southeast is 135 degrees from due north, but now it might be 90 degrees from due north. If we can detect this curvature, then flat earthers should be detecting at least some of it when they do their curvature experiments, unless they are all done along north-south lines of longitude. For instance, if you survey the southernmost boundary of a sizable body of water, especially along an east-west line, you should detect curvature, at least according to this map. We can even use the same equation that Samuel Rowbotham used to calculate his famous 8 inches per square mile. We simply adjust the numbers using the correct flat earth radius at that location, and we get a number that should represent curvature. At 50 degrees north latitude, it's 11.8 inches per square mile. At 30 degrees north latitude, it's 7.9 inches per square mile, and at the equator, it's about 5.3 inches per square mile. Also, ships traveling east or west shouldn't disappear over the horizon, but around the bend, according to this map. Airplanes traveling east or west should be constantly nudging their noses along the curvature, or else, of course, they might fly right off the flat earth and out into the forbidden zone. Just like they say that on the globe, airplanes will fly right off the globe into outer space, right? Now, what if we cannot detect this curvature? What does that mean? It will mean that for some reason, east-west space-time is bent. Yet north-south space-time is the regular old four-dimensional variety we are used to describing. Since we perceive the same in all directions, we obviously can't tell the difference, so nothing really matters and this map goes right out the window. The flat earth is curved. So what does the globe have to say about all this confusion? What can the globe reveal to us? First, the globe reveals that ships don't continuously sail on a flat surface sometimes, then disappear around the bend at other times. Ships always sail over the horizon. The only reason there is a horizon is because there's a curve. The globe also reveals that airplanes don't fly in curves one way, then straight in other directions. It may appear to be a straight line, but on a globe, it's always curved. Always. Most importantly, the globe reveals a simpler reality that is much less ambiguous. East is 90 degrees from north, and you don't need some weird correction coefficient to determine direction. East is always 90 degrees from north. This works in reality at the equinox sunrise and on the globe that represents this reality. I mean, what good is a map where you have to subtract 45 degrees just to face east? As I mentioned earlier, I'm just attempting to provoke a little thought here, okay? I'm sure that flat earthers will have something to say about it, but first, it is your map and it is completely quantitated in degrees of measurement. Two, yes, on the globe, you do look out into various directions depending where you look. But even if that's towards the equator or somewhere else, the globe is a physical spheroid in space. It's completely curved, and that's agreed upon. Flat surfaces should appear very different from spheroids. And thirdly, don't come back and say that latitudes represent sun angles. None of that works on a flat surface. Yes, 45 degrees north latitude might have a sun angle of 45 degrees on the equinox, but the remaining latitudes and sun angles fail on a flat surface. I haven't even started on the sky yet, but the flat earth fails so miserably against astronomical observations that you'll need thousands of correction coefficients just to make simple observations work. Yes, it's really that bad. Why do you think there are no flat earth based star maps? The bottom line is that the flat earth needs a better map and it's long past due. The modern flat earth movement is approaching 159 years at this point. Where's the consensus? Where's the map? Well, that about wraps up this episode of Revelations from the Spinning Ball. Thank you so much for watching. If you like this type of content, please consider subscribing. And don't miss my next episode where I'm finally going to get to some astronomy. We are going to discuss the sky and flat earth astronomy, or lack thereof. And remember, until next time, I know the world is round because one man's angle is another man's zenith, and astronomers communicate. We'll see you next time on Revelations from the Spinning Ball. Goodbye.